We're going to start out today just doing a couple of review of oxidation numbers. Okay? So we're going to start out just doing a little bit of oxidation number review. So as I am looking at these right here, I'm going to start off first of all with this one. Here is oxygen. Is oxygen in that case a peroxide? No, it is not. So oxygen there is going to be a 2 minus. I'm going to step up the potassium there. I can see that this is an ionic compound. So potassium is going to be plus 1. So when I come down here, say, okay, everything's got to equal 0. I have minus 8 for oxygen. I have plus 3. What is going to fill in that mathematical equation to make it correct? It's going to be a plus 5, right? So the phosphorus is plus 5. There I have my oxidation numbers for potassium phosphate. Now here is sodium peroxide. I threw this one in there. Do I have a peroxide? Yes, I do. So when I have that peroxide, oxygen's going to be a minus 1, correct? What is the charge of sodium? Plus 1. So now I have my oxidation numbers for sodium peroxide. Not a metal, okay? Oxygen's going to be, when you're going to see it as a peroxide, it's going to be an alkali metal, a group 1 metal, okay? So the most common ones you're going to see is with hydrogen, with lithium, and with sodium. Yes. Yeah, hydrogen peroxide, absolutely. Now, on this last one here, okay, this last one here could get confusing because you have so many things going on there. So how I like to do this last one is I like to break them down just into the polyatomics. I know that ammonium is NH4 plus 1. So as I'm doing my ammonium here, okay, I'm going to just do it, and I'm going to say, okay, it's got to equal plus 1. Well, hydrogen is going to be plus 1, so that gives me plus 4. So in order for this to be a correct statement, nitrogen's got to be minus 3, right? So I'm just going to come up here and put plus 1, minus 3. Now I'm going to do the same thing. I'm going to do the same thing here now for my sulfate. SO3 is a 2 minus charge if you look on your PAL. So this has to equal minus 2. Is oxygen a peroxide? No. So it's a minus 2 charge. That gives me a minus 6 total. What must my sulfur be to complete that mathematical equation? It must be a plus 4, right? So I finish out with my oxidation numbers. Now, could I go back and check? Could I go back and check? Yeah, let's do it. Let's do it. This whole thing should equal 0, right? Well, what's oxygen? Minus 6. Okay. What's sulfur? Plus 4. Okay. Here we have plus 1, plus 4, but we have 2 of them, so that's going to be plus 8. Here I have minus 3, but there's 2 of them, so that's going to be minus 6. Okay? And if I look, 6 minus 6 is 12. What's 8 plus 4? 12. So I do equal 0. So I could check it out like that. I just think it's easier with those polyatomics to treat them as their actual charge to figure them out. Okay? Now, why did we do these oxidation numbers? Okay? Why did we do these oxidation numbers? Well, they are what help us out with the stock system of nomenclature. We've already done the stock system where we put Roman numerals with certain metals, correct? For instance, look at iron. Okay, look at iron on your periodic table. It takes a +2 charge, it takes a +3 charge. So iron needs to have a Roman numeral. How did we determine what Roman numerals? Well, you didn't know it then, but you should now, is the oxidation number. Helped us determine which Roman numeral to put. We did that with metals. Now today, we are going to learn a second way to name binary molecular compounds, and that is using the stock system. I have the very top one, and I'll give you, why don't you, let me see how many of these I got. Okay, I'll give you a second. Write these 3 down here, first of all, in your notes. Now I'm going to go through the top one first, SCl6. So if I am naming this using the prefix system of nomenclature, I'm going to start off with the first one, sulfur. Remember, just a review, we don't put mono with the first one, only with the second one. My prefix for 6 is hexa. So I have sulfur hexachloride is my prefix answer. Now, if I am using the stock system of nomenclature, okay, I use Roman numerals once again, but I'm only going to put a Roman numeral in the middle. What I mean by that is I put a Roman numeral for sulfur. I don't need to put one for chlorine because I know what chlorine's going to end up being because it is the most electronegative of those. So what I am going to put is I'm going to put sulfur chloride but I need to have a Roman numeral. How do I determine the Roman numeral? Well, if I'm dealing with chlorine, okay, let's put the oxidation numbers on them. If I'm dealing with chlorine, chlorine is going to be a -1, right? So what must sulfur be here? +6. Guess what Roman numeral I'm going to put in there? 6. So this would be sulfur 6 chloride. Moving on. My prefix is diphosphorus pentoxide. If I'm doing my oxidation numbers, is oxygen a peroxide right here? No, it is not, so oxygen is going to be -2. What is phosphorus going to be? +5, right? Everybody see how we got +5 for phosphorus? So what's my Roman numeral going to be on my stock system? A 5. So I'm going to put, I am going to spell it right, first of all. Phosphorus, Roman numeral 5, oxide. Can you know what people want to do? What do you think a common mistake is? They add a prefix to the second one, absolutely. Okay? Absolutely. Okay? So just like Brandon said, they're going to want to call this phosphorus 5-pentoxide. So they're combining the two methods. Okay? That's the most common mistake, so let's not make that mistake. Okay? Let's not do that. The next one. Carbon tetrachloride. Okay, carbon tetrachloride. If I'm using the stock system, chlorine's going to be a -1. Copper is not on this one, but carbon is. Carbon's going to be a +4, right? So I'm going to get carbon 4 chloride. My final one, dinitrogen pentoxide -2 + 5. So it's going to be nitrogen 5 oxide. So if you know your oxidation numbers, this should be pretty easy, shouldn't it? Okay, that's why we did that oxidation numbers beforehand. Now, another thing that people commonly want to do is this. Nitrogen 5 oxide, they want to do this. Nitrogen 5 oxide 2. Why did they do that? Well, they said, well, here, oxygen's 2. I'm going to put oxygen 2 back there. Do we need to do that? No, because we know oxygen is 2 based on our rules for naming or for writing oxidation numbers. Okay? And what rule would this be? It would be, okay, the most electronegative one takes the charge of the ion it would take. In this case, oxygen would be -2. Okay? So let's make sure we don't make an error like that and have a Roman numeral there. Should we ever, whether it's ionic or whether it's molecular, should we ever have a time where we have 2 Roman numerals for the same compound? No. Where does the Roman numeral always go? In between, right? So automatically, if you've got 2 Roman numerals, you should be thinking, well, something's not right here because I can't have 2 Roman numerals. Okay? We got a thumbs up here? Okay.